dimension. Right? Pick the line. Pick the center line. Then you get the radius, right? You move here, you get diameter. Click. And if you want to get a symbol, you double click the diameter symbol here. If you use the radius or some other dimensions, you will lose points. Although it's not a very serious mistake, but you are required to use diameter. All right? About filling. The chamfer. If there are several edges, you do the fillets or chamfer, right? Put them in the one feature. Okay, if there are 4 fillets, you don't make four features. Make one feature to have all these 4 fillets. Right? And one thing about the procedure. Yes, I check the procedure. Right? For example, right? And if you don't make this one something, then you make the cut later, or make 2 revolved features, 1 revolved cut something. It's not good procedure, right? Because one revolved feature cannot have all these things. Right? All right, okay, these are about the tests. Any other questions? You need a practice so that you should make the thing fast, especially for revolved feature, right? To figure out what is the first feature, like this. Figure out what is the first revolved feature and all the dimensions. You should do fast. You cannot use 1 hour to figure out this one because you don't have time, right? There are 2 parts. So maybe one part of approximately 1 hour, right? So for the revolved feature, you have some more features, right? Hole and pattern or fillets. So if you use more than 1 hour to figure out this one, you don't have enough time, right? Practice. After chapter 8, the book, there are a lot of revolved features. Just practice at least 1 more, so that you can find out the cross section to be revolved fast. All right? Okay. Any other questions?
It's not necessarily in regards to the test, but exercise 6, is that still due tomorrow or is that due next week?
What?
It's not necessarily about the test, but exercise 6, is that due tomorrow or next week?
Exercise 6 is due next week. It is assigned this week. So it is due next Thursday. Next Thursday. Okay. In fact, we will learn something today to do the exercise 6. So this week, there are no exercise due because this week is a test. All right? Okay, to do exercise 6. So last time we talked about how to bring out the front view, top view, right side view, right? How to get the hidden line, how to get the center line, and all these problems. All right? I noticed some of you left very early, so you have to learn yourself. All right? Today we will learn how to how to give dimensions, right? For example, open. I could a little smaller.
So you said for me to get this sheet, because I couldn't find this sheet, you said you open a file, but we don't have that file.
This file is posted in Canvas.
I tried to look for it.
Yeah, Canvas files. There is this file called student something. Okay, download this file in a J drive. Then open time or every time you open. Go to Canvas. Of course, the file is there.
Under what section again?
What?
What section again? What
It's just
file?
in
Files. Files. All right. Okay. See, last time we learned how to bring these three views. However, without all dimensions. Right? For the drawing, the key is to give all these necessary dimensions. Okay, so now and also of course all these notes, right? You have to put your name, date, unit, and the part file name. How to make these notes. And let's learn how to give all these dimensions. But first, we need some knowledge about dimensions. So this is chapter 9. Dimensioning and tolerance. Dimension. What are these?
sound effects now.
So, what? You're still
Okay, how did he download? How do I download it? It's like it shows me this.
still the sound. Yeah. I remember I made it mute. Where? The other, if there's no volume.
This one. No, it's J, right?
All right.
Is it J?
So,
Whatever. Student. Okay.
all right. So dimensions. I don't do the full screen. Okay. Dimensions are used to describe the sizes and the relationships between features in your drawing. So size, say you make a hole, you have to give the diameter and the depth. These are sizes. And also you have to specify where is the hole, right? Dimensions are used to manufacture parts and to inspect the resulting parts to determine if they are qualified. Drawings with dimensions and notes often serve as construction documents and legal contracts. They're in standards, right? This is standards. Terminology. Number one, dimension. The number we call the dimension, right? Two, basic dimension. So if there is one dimension, we call it basic dimension. If there are two dimensions, we call it there is tolerance. We will talk about tolerance, right? 3. Why is it 3? 3 here. Reference dimensions. Sometimes the dimensions is not necessary, but sometimes it is useful, right? So called a reference. For example, in this case, if you have this height, the distance from center to bottom, and you have radius, you add these to the total height, right? But sometimes total height is important, right? It's useful for you to see what is the overall size. So then there is parentheses indicate this is not necessary, but as a reference dimensions. 4. These two lines with arrowheads, we call the dimension line. And these line, we call the extension line. 5 arrowheads. 6 extension line. 7 there is a visible gap, right? So extension line is not connected to the line, true line, but there's a gap. But we don't do the manual thing. Therefore, SolidWorks will take care of the thing, the format here. 8. Leader line. If the dimension for radius or for diameter, then these with the leader line. Right? And 9, limits of size. This usually give you the range of the dimension, right? Within this range, it is good. It's qualified. We call the tolerance. We will talk about tolerance later also here. 10. Plus minus is also tolerance. Give you the range of the dimension. 11. Diameter. We know this, right? R is radius. Circle, a slash is diameter side. So these are terminologies for dimension. So good dimensioning, good technique of dimension, good choice of dimensions, and a good placement of dimensions. Good choice, right? For example, for the full circle, you have to use diameter. For arc, you have to use the radius. These are good choices, right? And sometimes there are different possibilities to give dimensions. Good placement. We know front view there is width and height, right? Right side view there is depth and height. Top view there is width and depth. Then for each dimension, you can put one of the two views. For the width, you can put in front view or top view. But sometimes it doesn't matter. Sometimes it matters. Only one view is good placement. Right? So, and then we talk about this. Dimension in text. Describe how the dimensions in your drawing should look. Defined by various standards. Help you create dimensions that are plainly visible and can be easily interpreted. Specify sizes for creating dimensions relative to the paper size of your final plot. So these, we talk about dimension text. One thing, in one word, in one sentence, all dimensions should be clear. clearly visible. This is the purpose. For each feature, there are, except the first one, there are always size dimensions and the location dimensions. Therefore, to check if you have all necessary dimensions for each feature, you check if all size dimensions are there, if all location dimensions are there. In that case, you will not miss any dimensions. Remember, if you miss dimension, it is a major mistake, because without that dimension, you cannot make the part, right? So if there's a hole, it's through hole, the size dimension, there only one, which is the diameter, right? Location dimension, see, in this case, size depth is also size dimension. There are two location dimensions. There's one, this is two, right? Sometimes we use coordinate dimensions. So we use the datum plane, datum line to specify dimension like this, right? So you give all three, the location of all three holes. These are locations.
Now I can get this.
So it's very clear, right? And sometimes if you use, for example, 30, right? Then you use distance from this center to this center and 15. It is not a good choice. Why? If you only want to change the location of this, you don't want to change the location of this, then you have to use these dimensions. If we use 30 and 15, you change the location of the first one, second hole, the location is changing too, right? So use data plane or baseline for dimensions. Dimension text placement, right? And depending on the gap, how large is the gap, right? If it is large, put the dimension line and the dimension inside. Or if not large enough, put a number inside the dimension line with arrowheads outside. Or put these dimension line inside, number outside. Or put everything outside. Right? It is relatively very easy. When you get a dimension, go to leaders, you can change all these. The number you can drag. Right? The dimension line, you go to leaders, you can change these format. This is horizontal, this is vertical, right? As to the dimension line, sometimes if inclined or vertical, it doesn't matter, right? Of course, you have a choice, right? Make all these horizontal, the dimensions, but it doesn't matter. Group dimensions, right? See, these are not good. So you put all these same dimensions of the same nature. Here is width, put together. So it's very clear the size of these three things, right? We call it group dimensions. Stagger dimension text. Put the dimensions with the same nature together. See, here all diameters, here all depths. Put them together. So it's very clear, right? Dimension outside of views. In general, all dimensions should be outside of the drawings. like this. It's not like this. Right? Contour dimension. Place dimensions in the most descriptive views of the feature. For example, in order to give radius for this arc, right, it's better to give here, not here. Why? Because this hidden one, you don't know, of course, when you look at this, you know this is the bottom line of the hole, right? But if you put R here, this is straight line. Why you put R here? Of course, radius should point to this arc, right? And see the height of this piece. You better to put here, not here, right? Because if you put a dimension here, it is very clear. It is the height of this piece. If you put here, you don't know what is this, right? So should be put in the most descriptive views, right? So these are good ones. These are not good ones. Geometric breakdown technique. This is a check. If you have all necessary dimensions, you just check feature by feature. Check each feature if there are enough size dimensions, if there are enough location dimensions, right? For example, for this middle piece, right? There is 2 diameters, one here, one here, right? Or you can put both here, it will be better. And the height, right? These are, and the depth of this is through hole, right? So these are size dimensions, and these are location dimensions, right? This is called geometric breakdown technique. Let's forget this. Repetitive features. We use 4 times, right? Instead of give 4 diameter, we use 4 times. And for this case, if you don't use 4 times, it's also okay because it's very clear. These are symmetric, right? Avoid over dimension. If you have A and B, then you don't need a C, right? But sometimes you have C is also okay because C gives you the total width. But at that time, C is what we call the reference dimensions. But in most of cases, avoid over dimension. Right? Sometimes you put the width in the front view, the same width you put in the top view. Then it is not good. Hole. Hole, we will learn how to get the notation automatically. Right? And cardboard hole, and a countersink hole. Slots. So there are different ways to give dimension, but this is the best one, right? Actually, you don't need a 10. You only need a 30, and 2 times are 5. 10 is extra dimension. You don't need, right? Chamfer. So we will learn how to get the notation automatically if you make it as chamfer, right? You don't need to do these. Well, in SolidWorks, you will get, say, 2 times 45 automatically. Forget this. So here are general rules of dimensions. The dimensions you specify determine the way the part is manufactured. Therefore, you must have all dimensions, necessary dimensions. Consider the purpose of the part and its function in the assembly. And consider how easy it will be to check the measurement of the actual part. Fully dimension each part. Do not over-dimension or under-dimension. Over-dimension is not so serious, but under-dimension is a major mistake. This is about dimension. There are more. Give size and the location dimensions. Give diameter for a full circle, the radius for an arc. Place dimensions in the most descriptive views. Each dimension, you always have 2 choices, right? Therefore, which view you put a dimension, sometimes doesn't matter, sometimes it matters. Avoid dimensioning to hidden line. Avoid means sometimes you don't have a choice. You have to give dimension to hidden line. But if possible, avoid the dimensioning to hidden line. Give overall dimensions where possible. General dimensions should be placed outside of views. Right? So these are general rules. Summary. Good dimensioning is a combination of several things. 1, choosing dimensions which reflect your design intent. 2, proper technique in creating the details of the dimension lines, extension lines, arrowheads, and the dimension values. 3, placing the dimensions on the drawing so that they can be read clearly. Dimensioning drawings. Dimension drawings collected can be as important or more important than drawing the shape collected. Good dimension requires practice and thoughts. I'm telling you, for the third test, drawing is 60%, part is 40%. In the final test, part is 40%, drawing is 30%, assembly is 30%. Therefore, according to previous semester, most of the points students lost is drawing.
Wait, this next test is drawing 60% and part 40%?
Third test. Next one is the second one.
Okay.
That's the dimension. Then tolerance. We will not do tolerance in this class in SolidWorks because we don't have time. But you do need the concept of tolerance. It's a very important concept. Okay, the total amount of specific dimension can vary, right? And the tolerance are assigned so that any 2 mating parts will fit together. I will explain. Right? Highly accurate parts are extremely expensive. So tolerance should be as generous as possible while still maintaining proper function of the part. So what is tolerance? Any dimension, you must give a range. right? So therefore, when the part is made, then the inspector will check if your part is qualified. If your dimension, for example, width is within this range. The larger the range, the cheaper. The smaller the range, the more expensive. Right? And also, one thing is, if you have a mating part, you have two mating parts, right? Say, one,
It's out of focus.
you inserted this into this slot, right? If you say this is 1 inch, and this is also 1 inch. When you make these parts, they're always arrows, right? Then actually this may be a little than 1. This may be a little smaller than 1. Then you cannot put this one into the slot, right? Therefore, we can use tolerance. We say this is 0.98 to 1 inch, or to 0.99 inch. This is 1 to 1.1 inch. Therefore, you will guarantee this piece can be inserted to every of this piece, right? This is another purpose of the tolerance. Therefore, any real manufacturing drawings, you must specify a tolerance. All right? There are two ways to specify tolerance. One is limit dimension. You give two numbers. Therefore, in between these two numbers, if the diameter is qualified, the outside of this range is not qualified. It's useless, right? For example, this is shaft, right? So the shaft is a little larger than a little smaller, and the hole is a little large. That will guarantee each shaft can insert into this bearing, right? Called the limit dimensions. Right? One method is plus minus dimension. You give a base value, then plus and minus. So it's same as two numbers, right? Give you the range. Give you the range. So the equal bilateral or unequal bilateral. This is equal on plus side and minus side, right? And sometimes it is unequal on plus and minus side. But anyway, these will give you two numbers, right? Low limit and high limit. Allowance and tolerance. So if the difference is large, it's the loosest, very loose fit. If very tight, it's a tight fit, right? So sometimes you require very tight fit. However, tight fit were more expensive, right? So there is types of fit, right? And different types of fit. Okay, so this is hole base, right? So you take the hole as the base. So the shaft should be a little smaller. One is shaft base. You take shaft as base, and the hole should be a little larger. All right. So there are different notations and different tolerance grade. And okay, about tolerance, there are a lot of things, standards, right? So if later you try to make real manufacturing drawings, you must consult the tolerance standards, right? Okay, summary of the tolerance. There are several methods you can use to specify tolerances in drawing. One is limit tolerance. Give you the up and the low range of dimensions. There is plus minus tolerances. Give you normal or basic size, and the plus and minus range of the tolerance. Right? And international tolerance grades can be used for describing tolerance.
How did you do this?
So tolerance is an important concept for the real manufacturing process, right? But we will not do tolerance here because we don't have enough time.
So the sketch is kind of wrong, so.
Right. So what I do is how to get all these dimensions. All right? Class. Open a template, right? You don't go to new, but open template. There's a file called Student.drwdot in the Canvas files. Download this file, put it in your J drive. Every time you want to make drawings, open this template. Open. This extension is we call the template type, right? We have part file, we have drawing file, we have assembly file. Also, we have template file. Open. When you open the template, you get this page. Then you can make a drawing, right? Insert, drawing view, model. Then this is what we need, right? You choose this part file, you get a view, right? So it may not be front view. Sometimes it will give you front view automatically, but sometimes may not. Then change it to front view. Here is orientation. Front view, right? Then click this view. Then go to insert, drawing view, projected view. Then you move the mouse here, you get top view. You move mouse here, you get right side view, top view. You move mouse here, you get the top view, right? Next is change scale to make all these views as large as possible. But you still need to leave rooms for dimension, right? How? Remember, front view is a base view. Other view are projected view. Therefore, any change in front view is global, right? Will change all other views. But any change for the other views, one of the other views is local, only change for their view. So first we have to make the large, it's too small, right? So pick this view, then scroll down. In scale, So usually you choose use custom scale, right? Then to see if you get to the 3, right? Maybe it is good, right? If it's not good, you can change any number of 2 and 3. This is the ratio, right? One number to another number. You can change any number to decimal places. 2.5, even 2.2, 2.3. Therefore, you can have any size of these drawings, right? So this may be good size, right? And then the pictorial, we don't need so large pictorial because we give dimensions to multi-views. Pictorial is just a reference for you to visualize. So pick this view, change the scale to small one. It's too large. Use custom scale, 1 to 2. You think it's okay, then it's okay. Then 1.25. Okay, this may be 1 to 2.5. Okay, then drag this to the corner, right? So that it will not occupy the space for dimension, right? And next one you need to do is take away all tangent lines, because tangent lines, there are no lines, right? So you just see the tangent line, pick then right click, there is tangent edge, remove. You do this to all these views. Tangent edge, remove. Tangent edge, remove. Tangent edge, remove. Now, I'm telling you, today is second time I repeat all these procedures. All right? Now, what do we need? We need hidden lines and center lines, right? So how to get hidden lines? Click. Then you scroll down. There is a hidden line here. You get all hidden lines, right? And then you have to take hidden line away from pictorial. So pick this view, then the same, go back to only visible lines. Next is to get center lines. How to get center lines? There are 2 for all these circles. SolidWorks call the center mark. For these, we call the center line in SolidWorks, right? So in general, all these are center lines. So go to annotation. There is center mark and center line. First pick the center mark, right? Pick the largest circle. Do not pick the smaller circle. If you pick a smaller circle, the center line will not be long enough. Pick the largest circle. Pick a large circle. Pick all these circles. Right? So you say done. So you get all these center lines. Now go to center lines. I make the large. Here say select a view. Right? Click select view. So select their view, see all these center lines. Select their view, see these center lines. There are no more center lines. Right? Then check on that. Okay, so what is next? Next is bring dimensions. Right? All these procedures are in this document. If you forgot, you follow this document, right? Open template. When you finish, you cannot use save. Because use save, your work will replace template, okay, as template file. So you lose everything, right? Save as drawing file, that give your name. What is the name? It's the same name as the part file. Say F5.148, right? You will wonder, well, if I use same name, then the part file and the drawing file will be confused. No, because they have different extensions. Part file is SLD PRT. Drawing file is SLD, which is SolidWorks, right? And DRW. Assembly file is SLD ASM. Right? And the drawing file must be made from part file in J drive in the same folder. Right? As I said, otherwise I cannot open your drawing file. It's same for assembly file. Please use the part file in J drive to make drawing file, to make assembly. Right? Do not use your part file in your laptop to make drawing file, then copy to J drive. I cannot open, right? Because your part file is in your laptop. So there's a way, if you do everything in your laptop or somewhere else, you do not use save as. You use file pack and go. Where is file pack and go? File pack and go. Right? Then you save the file to a zip file. Save all your part file and the drawing file into a zip file. Then copy zip file to J drive. Then unzip. You get all part file and the drawing file. All right? But it is complicated. So why just use your part file in J drive? After drawing file is made, the name of the part file cannot be changed. All right? So here is the procedure. If you don't forget the procedure, it's a follow step by step. This add a dimension. There are two ways to add a dimension. One, import from part. One is give dimension. It's like you do in the sketch. For the smart dimension, you can give all dimensions. Let's get dimension, right? Say this is front view. Pick a front view. You scroll down and import options. Import annotation. Design annotation. Include item for hidden line. Right? See, when you click, you see the dimension comes out. Right? And then see, they will be located anywhere. Right? So you cannot see clearly all these dimensions. You have to edit these dimensions. So move it up, move this down, move this down, just drag. It's very simple. So see, you cannot see clearly, right? Move it outside, move it outside. So move this outside. And flip the arrowhead. See, the gap is too small, right? You pick the dimension, go to leaders, you pick this one. So that arrowheads will be outside. Right? And move the 90 degrees here. Right? Move the 2.6 here. Go to leaders, flip arrowhead. Right? Now every dimensions is clear, right? Avoid overlap. The purpose is to make all dimensions clearly visible, right? Okay, now we need to add more dimensions, all right? It's not enough, right? So let's give the diameter for the hole, right? So go to smart dimension. Here, go to change the leaders, pick this one, right? And click this one, smart dimension. Pick this. Go to leaders. Pick this one. Right? 2 diameters. Now about the cardboard hole. Right? Annotation. There is hole call out. Then you just pick the cannot find the so-called to then call out format text. Forget this. Right? So here is call out. The cardboard hole, right? The small diameter through. Large diameter depth is 0.19. Okay. Now we need more dimension, right? One is the rib or the round corner. Smart dimension. You can put it here or here, right? Whatever there is space. You try to spread all the dimensions among these figures, not to put in one very crowded, right? So I change the leaders. All right, and the rib, right? Smart dimension. I'm sorry. Annotation. Annotation. Not this. Smart dimension. It's the same as a sketch. Flip dimension. Flip arrowhead. And remember, the rib is not in middle. See, the center line is not in middle, right? So give the distance from here to here, which 1.3, right? And then check the more dimension is for the location of these cardboard holes, right? So smart dimension here to here. Cut angle. So it's not what we want. Pick a circle. Pick this one. The center line for this is not long enough, right? So we have a redo. Delete center line, go to center mark. Now it's long enough, right? And go to smart dimension. Pick the line. now. Okay. And also the distance from here to here, right? Sorry, smart dimension. Okay, these are the location dimension for the circle because they are symmetric. Therefore, you only need to give location dimension for one of the hole, right? Okay, then you have to check what else you want. So it's too close to border. So I move this a little bit downward. Move a little bit downward, right? And move a little. All right. Then we have to check if all dimensions are there, the total width, right? So give a smart dimension. Right? So the total width you can give here, the depth, or here. It's okay, but here we have a lot of dimensions, therefore we put here. You spread all these dimensions to the three views, right? Okay, let's see if we have all dimensions. What do we check? Go to exercise, right? Oh, 5? No, not this one. 6. So we have countable the hole and the location, right? And 38 diameter. The location not necessary because it is clear. It is in middle. The rib 99 we have height, right? It seems all dimensions are there. It seems all dimensions are there, right? For exercise, you also can compare to this, right? So, it's 4 times. You can put 4 times. 1.6, we have all these dimensions. We have these dimensions, right? And the notes, right? What are the notes? Fillets and the rounds are 0.09. So go to annotation and the note. Then let's jump over here. Right? Then fit lips. And round are 0.09. Right? So you can make it change the font. For example, you say I want a little large or different fonts, 14, or make it boldface, whatever you want, right? You can change the style. And put your name here, the same as you put the note. You have to fill all these 4 blocks. Day, unit, and per day. Fill all these units, okay? The blocks. These are how you give dimensions, right? Okay, now we come to this one. Add dimensions. Import from part or use smart dimensions. 2 ways. When you use 2 ways, the dimensions will appear different color. So you have to change. Import is black. If you add dimensions, it is gray. So you need to change the dimension, change the color. So change the dimension color. Go to System Options, Colors, Dimensions, not imported. You change the gray to black. Dimension for holes, insert annotation, hole call out. Dimension for chamfer, go to Smart Dimension, the chamfer dimension. Right? Go to Smart Dimension, there's triangle. There is chamfer direction, chamfer dimension. Let's see. Last one, chamfer dimension. You pick this one, then you can get something times 45 degrees. Add notes. Symbol. You enter these things, you can get these symbols. Right? So for example, right? See the triangle bracket mod DIAN, which means there is diameter sign. Right? So these are for different signs. General rule for dimensioning. Do not miss necessary dimensions. This is very important. In general, dimensions should be outside of the drawings. For full circle, use diameter. For arc, use radius. For cardboard, countersunk, and threaded hole, use hole call out. Add necessary notes. Avoid the repetition of the same dimensions. For example, right? Say small dimension. Right? Therefore, this dimension is the same as this one, which gives the depth. So do not repeat. Right? So delete this. Avoid the crossover of dimension lines. Avoid such a thing. You put the small one inside, the large one outside. So avoid these crossover. Right? Avoid overlap of dimension and the lines. Is overlap. You cannot see clearly what is the number. You drag a number to outside, right? Okay. Do not have anything outside of drawing frame. Do not put anything outside of the frame. Here is the frame, right? Do not put anything outside of the frame. Anything should be inside of the frame. Right? Okay, so these are general rules. So now you can do exercise 6. You have any other questions? If you forget the procedure, bring out this document. Follow the step-by-step procedure there. Right? And this exercise due Thursday next week, or Wednesday next week. Wednesday next week. So you can do it now and continue the work after the test on the Thursday. Right?
For this upcoming exam, what is gonna be exactly what we're gonna be tested on? We're gonna be tested-
Exam? What? For the exam?
Yeah, we're gonna be tested.
One part is basically is extruded feature.
Okay.
One part is revolved feature.
Okay.
And the whole wizard, fillet, chamfer, and pattern, these things.
Okay, will we be doing multi-projections on the multi-views as well for this coming
What
exam?
time for what?
Like this.
Are we gonna be doing these multi-views?
Yeah, you have enough time. I
No,
assign.
again, on this, our
The test.
upcoming exam, will we have to do multi-views?
No,
No.
no, not drawing. The part, only parts,
Okay.
only part. But you can do this as practice.
Okay.
The
But
part.
this won't be on our exam.
Not in your exam. Examine are new problems.
No,
Not
no.
the problems we did in the exercise. Not the problem in exercise. New problem.
Yeah, we still have
Wait, like I want to know actually, is this gonna be on the?
No, he said like 100 times. This part of it is not gonna be on the exam.
You have problem
No.
with the whole wizard?
This.
You should solve this problem long time ago.
That's why this multi-views thing is due next week after.
Okay, so what we saw in exercise 5 is more, so.
Go to system
Yeah,
option.
like this one.
Exercise 4 and
It's
5.
just gonna be a revolve feature or a revolve part and a surge part.
Yeah, look, it's gonna be including this one
Yeah.
and this one.
Okay, those are the two big ones.
Awesome.